All right, power focus area 9, objective 3, the wave focus area. Remember, a wave had a crazy definition that eventually we got good at understanding. It was a disturbance in a medium that transfers energy. So the big thing was energy is what's transferred. We said that over and over and over. In fact, every time we just had this focus area, energy was always our right answer. Disturbance is just how the energy gets in, and the medium was the thing that transferred it. So in this picture, the disturbance would be the kids waving their hands, so kinetic energy. The medium is the slinky because it's moving. Uh, and what it's moving, they're transferring is that energy from the hands' kinetic energy. So go ahead and press pause while you put this in your note guide. All right. This would be another example. If we look at the top picture up here, we see this dog just sitting on a raft in a pool. And all of a sudden, this boy runs and jumps in and makes a huge wave that eventually probably knocks off the dog. So, our disturbance, how does the energy get in there? It's the kinetic energy from the kid jumping. The medium, where does that energy from him jumping move through? So, that's the water. And that covers our energy being kinetic, disturbance, and the medium is the water that transfers that energy throughout the pool. Go ahead and copy that into your note guide. Practice question, so press pause while you pick your answer before I give the answer. Energy, our favorite answer for our whole focus area when we did waves, energy is transferred. What is medium? Press pause while you answer. That's what the energy transfers through. It can be air, like my voice is traveling through, water, like we saw, the spring, a rope, whatever the energy of a wave is moving through. That's your medium. We mentioned this earlier this year as well. Right now, you can't see me, but you can hear me. And what's happening is the speakers in your computer or headphones are creating waves. Those waves hit the molecule right in front of the speaker or headphones. That hits the next molecule, the next, and eventually it hits your eardrum and you're able to hear it. It's also why you can't hear in outer space because there is no air to move the wave energy from your voice. Look at our words again, our big important words. A disturbance. That's what starts it. How does the energy get into this system? The medium is what moves the energy, and energy is the only thing that's moving. Think of it like dominoes. You have a whole bunch of dominoes stacked up. You tip one, it doesn't move to the end of the line. It just hits the next, that hits the next, that hits the next, just like the energy in a wave being moved. Go ahead and add this to your note guide. Press pause if you need to before I skip ahead. All right, another practice question. So pause this as you answer it, and then I'll give the answer. So the question wants the source of the wave and the medium. In other words, the disturbance and the medium. So the source would be the rock. That's how the energy got into it. And the medium is what takes the energy from the rock and moves it. Well, the water does. So the water is the medium. Same question, different scenario. So press pause while you answer it on your Pear Deck. All right. The speaker is the source or the disturbance that brings the energy, and the air is what travels, the energy travels through, so the air is the medium. We've already given this answer. Press pause. The medium is the slinky. It's transferring the energy from their hands. Press pause. Water is clearly the medium here that's transferring the energy. All right. Mechanical waves, like sound waves, are waves that need a medium. Things like light waves, we talked about earlier this year, don't need a medium, so they're not mechanical waves. Remember, mechanical waves travel faster through objects that have particles packed close together because it hits one particle that hits the next, the next. So solids actually transfer mechanical waves like sound quicker than liquids and much quicker than gases. Go ahead and copy that down. Here's some example of mediums, but we're going to, excuse me, get to the more important part after the notes you fill out. Remember, always pause if you need to. States of matter. This is exactly what we're talking about. So if we look at here, we're looking at a solid. Those particles, all these little blue circles, are really close together. So a wave comes, let's just say a sound wave, and it hits this particle. Well, it doesn't have to go far at all before it hits this one, and even this one a bit. And right away, it hits the next, the next, the next. So the energy is transferred very quickly. In the liquid, we hit this. Well, now it has a little bit of space it has to move to. So it's going to take a little longer, a little more space before it hits it. So liquids transfer waves a little bit slower. And then the slowest would be the gas. Here comes a sound wave. It transfers energy to this molecule, has to move all the way over here to there, wherever it's moving. It's taking longer because the molecules are spread out. So solids transfer waves the quickest, then liquids, and then gas is the slowest because solids have the closest packed molecules and gas have the furthest spread molecules. Go ahead and fill that out in your note guide. Pause if you need to. All right, see if you remember what we just said. Put the blue star where on any of the pictures that waves would travel the fastest in, and the red star in the slowest. Go ahead, press pause while you do that. Remember, fastest should be the closest particles. So our blue star for fastest should be over here. Our slowest are the particles that are spread out, which would be our gas over here. So that should have red. Electromagnetic waves, we'll have a whole objective on this next, but for now, just think of them as light waves, and remember, they don't need a medium, so they can travel through outer space. We talked about light a lot. We've also talked about the other ones you see in the picture, radio waves, microwaves, but we'll get into those more in the final objective of Power Focus Area 9. And remember that fancy word, electro means electric, so it has electric fields, and magnetic means it also has magnetic fields. Practice. Press pause while you answer. So remember, mechanical waves start with an M. They do need a medium. M and M, they need each other. Electromagnetic waves, like light waves, they don't need a medium, so that should be our answer. Longitudinal waves are waves that move, hopefully you remember, side to side, or the fancy way of saying parallel. These lines are parallel with each other that you see here. Transverse waves, you can see, move up and down, or the fancy way of saying perpendicular. And all of that is here to put in your note guide. Practice again. We've seen this once, but it's guaranteed, almost guaranteed to be on your test. So red star for the fastest moving substance down there, solid, liquid, or gas. Blue on the slowest. Go ahead, press pause. Remember, it's all about packing the molecules. So when they're close together, it's fast, which means it gets red. When they're spread out like over here in the gas, that should get blue. If you remember, we actually define these words through the picture. So when we talk about crest, where is that? It's at the top of the wave. Trough over here, bottom of the wave. Wavelength, it shows from one top to the next or from one crest to the crest. And amplitudes just from the middle or the rest position to the crest or even trough. So those are the definitions we just said, but it was easier by looking at the picture. So let's see if you remember this from way back when. Red dot goes on the crest, blue on the trough. And press pause before I give the answer. So remember, we said crest is top, so here, here, or here could have red. Blue is trough, which is the bottom, so here, here, or here would all work. We want to see the amplitude, so press pause while you draw that. Remember, amplitude, we always start at this middle line and just go to the top. So you could have drawn it here, or even over here. Draw a wavelength. There's two different places you could draw. Go ahead, pause while you draw. You could start here and go to the next top, crest to crest, or we could start here and go to the next one, crest to crest again. All right. Describe the two differences that you see here on your practice trying to use your new vocabulary. In other words, which of these has a bigger amplitude, 1 or 2? And which has more wavelengths? So remember, amplitude is height. One has a bigger amplitude than this little height at 2. One also has a bigger distance between, which is the bigger wavelengths. Now we can add 2 more words to these, or at least one obvious one, and then I'll explain the other one. Frequency means how many waves do you see in a space. So in this picture, there's only 2 waves. Down here, 1, 2, 3, 4, 5. So this has a higher frequency because we have more waves in the same space. And a period would be how long does it take to one wave to pass, which we don't really see there. So go ahead and fill these 2 yellows parts into your note guide. Press pause if you need to. And hopefully you are good for this focus area.